friends, I am Himabindu from Women Who Code Delhi and welcome to another video of Tech Bytes. In this video, let us look into how to apply MP Neuron model on a simple example. Before that, let's quickly summarize what we had learned in the last video. So here is the MP neuron and this is the biological neuron. The x1, x2 and so on up to xn, these are the input data and these correspond to the nerve signals which are received by this neuron. The weights here W1, W2 and so on, these correspond to the strength of the synaptic connections, and the result of the adder function corresponds to the membrane potential developed because of the input nerve signals. And the threshold here in the activation function, this corresponds to the threshold potential of this neuron. And the output produced here, that is 0 or 1, can be related to two states here. 0 means that the neuron didn't fire, that is, the nerve signals which is received by this neuron is not passed on to the other neuron. And when output is 1, this can be related to the state when the neuron takes in the input signal and it passes on the nerve signal to the next neuron. Now let's get into the details of the example. So this is a data set in which 4 features are given, and based on that we have to predict if a person would visit a particular theatre or not. So the 4 features given here are ticket price, total seats, multiplex or not, and the reachability, whether it is easy or difficult to reach that particular theatre. And finally, we have to predict if a person prefers to visit that particular movie theatre or not. Here you can see that the data is either real numbers or text data. But as we know that MP Neuron model takes in binary data, so we have to convert these values into binary form. So in case of text data, we can see that there are 2 categories here, either yes or no in these both columns. Easy and difficult are 2 categories in this column. So what we can do is we can map one of the category to 1 and other category to 0. So in this way we can convert this text data into binary form. So now let us see how to convert these real numbers into a binary form. Since these all numbers belong to a certain range, like the minimum here is 100 and the maximum value is 700, and all the numbers lie between these. So one idea could be to calculate the average of this. If the given number is greater than average, we can take it as 1, and if the given number is less than the average value, then take it as 0. And the same thing can be applied on this column also. So after calculating the average value or taking up some value nearby the average and then mapping it, that is, if the value is greater than this value, then it would be 1 or else it would be 0. We get this particular data set. It can be mapped in other way around also, but I assumed these values. So here as you can see, 700 is greater than 300, so we took it as 1. 250 is greater than 300, so we took it as 0, and so on. And here since it is no, we took it as 0, and for S we took it as 1, and so on for all these columns. Now we are done with the first step, that is to get the binary data. In the next step, let us see how to calculate the weights. I hope you remember the adder function. So it is the sum product of the features and the weights. Features are nothing but the name of the columns. So in our example we have 4 features and we have to find out the weights for these 4 corresponding features. We can assign any random values for these weights, but it is preferable to keep it closer to 0 or 1 to get this output. Now I am assuming that the weight 1 will be 1, weight 2 as 1, weight 3 would be 0 and weight 4 would be 0. And let us now calculate the value of the adder function here. 1 into 1 plus 1 into 1 plus 0 into 0 plus 1 into 0. This gives us 2. And in the same way we can calculate for the rest of the rows also, and these values will be obtained after calculation. So now let us see for what values of the adder function is the output 1 and for what it is 0. Here we can see that the output 1 corresponds to 2 here, and 1 here, and 2 again here. Now let us assume that if the adder function value is 2 or 1, then the corresponding output will be 1. But what about this case? Here also the adder function value is 1, and here also, but the corresponding output here is 0. So we cannot use these weights. Now let us take some other set of values for these weights. If we think logically, we can see that the features are being multiplied with the weight and then added to get the output. This means that this weight is representing the amount of the feature or the proportion of the feature which is contributing towards the output, isn't it? So now let us analyze how much a particular feature is contributing towards the output and assign the weights accordingly. In this case, feature 1, let us see what 1 in this feature corresponds to the output. So the 1 here corresponds to 1 in the output, and 1 here corresponds to 1 again, 1 corresponds to 1 here again. So we can see that this is directly influencing the output. So let us take W1 is equal to 1. Now let us see for the feature 2. In this we can see that the 1s here correspond to 1, 0, 1 and again 0. So here in the 4 cases, 2 cases are corresponding to the output and 2 cases are not corresponding to the output. So let us take this also as 1 because it is somewhat contributing to the output. Moving further towards feature 3, here we can see the 1 here corresponds to the 0 in the output. The 1 here corresponds to 1 in the output. Here the 1 corresponds to 0 again, and here also the 1 corresponds to 0 again. So in these 4 cases we can see only in this case the feature is contributing towards the output, whereas in the other cases, even though the feature is 1, the preferred output is 0. So let us take the weight to be 0 here because it is not contributing much towards the output. You can take up any value here like 0.5 or 0.75 or anything like that. For simplicity I am taking either 1 or 0 in this case. Let us see if it works out, otherwise we can change the values also. For the 4th feature, we can see that when the value is 1 here, it is also 1 in the output. So here we can see that only in one case it is not following, and in the rest 2 cases, the 1 here corresponds to the 1 in the output. So let us take this weight also as 1. Now let us apply the adder function here. So 1 into 1, the corresponding weight to the feature, plus 1 into 1 again, plus 0 into 0, plus 1 into 1. 1 plus 1 plus 1, this gives us 3. Similarly, we can find for the rest of the rows also, and these are the values which would be obtained after the calculation. Now let us see the relation between the adder function and the preferred values, that is the output. The values corresponding to 1 in the output are 3, 2 and 2 again. So this means that if the adder function is 3 or 2, then the output would be 1. Let us confirm if it is true or not. Let us see the value corresponding to 0 here. It is 1. Here also it is 1, and here also it is 1. So yes, we can confirm here that if the adder function is 3 or 2, then the output is 1. Otherwise it would be 0. Now let us calculate the threshold value for our activation function. So this is our activation function, and if the adder value, as we saw here, is either 2 or 3, that is greater than or equal to 2, then the output is 1, otherwise it is 0. So we can take the theta value as 2 here. So if the value of adder function is greater than or equal to 2, then the output is 1, and if it is less than 2, then it is 0. So now we have completed all the points here. So we converted the real data into binary data, and we also tried to assign some weights by analyzing the value of adder function and the output. Based on that, we also calculated the threshold value. Now here is a task for you. Apply MP Neuron model on the following functions: AND function, OR function and XOR function. This is the AND function, this is the OR function and this is the XOR function. Construct tables for these. X1 and X2 would be the input values here and Y would be the output value. Since the input data is binary, so you need not convert anything here. Now the task is to find what set of values of weights satisfy these equations in the similar manner as we did in the last example. We shall discuss the answers for this in the next video. Now let us look into the summary. We converted the real data into binary data and by hit and trial method we found the values of weights. We also related the MP neuron with biological neuron. And please complete this task before watching the next video. Thanks for watching.